Okay, so today we will have a look at different types of motion of the follower. Means the cam and follower के अंदर दो elements होते हैं. One is cam, that is rotating element, and another is follower, that is this oscillating element. So based on this oscillation of this follower, it can also be classified like this also, based on follower motion, uniform velocity, simple harmonic motion, uniform acceleration and retardation, and cycloidal motion. So these are the motions of this follower. ये जो यहाँ पे अप एंड डाउन मूवमेंट हो रहा है उस एलिमेंट का different types of motion है. So let's begin with uniform velocity. How to design a cam that will provide uniform velocity to this follower. So to understand this design of cam, we need to first understand this motion of follower. बिकॉज कैम एंड फॉलोअर के डिज़ाइन है उसमें हम यही प्रोसीजर फॉलो करेंगे कि हम एज्यूम करेंगे कि हमारा कैम जो है वो स्टेशनरी है और फॉलोअर को एक कैम की पेरीफेरी पे मूव करवाएंगे. So that should generate the cam profile. So let's have a look at the first one, that is uniform velocity motion. Motion of the follower with uniform velocity means जो यहाँ पे move हो रहा है that is moving with uniform velocity. So at that time which kind of cam profile can be generated? So first we will see the displacement diagrams for all these four motions. Then we will go to cam profile designing. Okay, so first हमने जो चार मोशन है वो अंडरस्टैंड करेंगे और उसके बेस पे जो डिस्प्लेसमेंट डायग्राम है वो कंस्ट्रक्ट करेंगे. So first let's go to motion of the follower with uniform velocity. So to draw the displacement diagram we have to follow the common procedure. Okay. On x-axis there will be angles. Now how we can plot angles on axis? एक स्ट्रेट लाइन के ऊपर हम एंगल कैसे इंडिकेट कर सकते हैं? We have to assume scale. So you can assume any scale appropriate according to you, but in general you can assume that 1 mm is equal to 2 degree. It means 1 mm on x-axis is representing 2 degree angle. Okay. तो ये जो x एक्सिस है उसके ऊपर 1 mm जितना डिस्टेंस होगा वो 2 डिग्री एंगल रिप्रेजेंट करेगा. So now I am designing the cam profile based on one complete revolution of cam. So to complete one revolution of cam, it should be rotated by the angle 360 degree. So if I want to draw a line that is representing 360 degree, so according to this scale, I have to draw a line of 18 mm. Oh, sorry, 18 180 mm. That is 18 centimeters. Likewise, so accordingly, whatever scale you assume, in accordance to that, you have to draw a line. Okay. Right now I am explaining the general procedure. And so you have to first draw x and y axis and draw a line at a distance s. You have to draw a line parallel to x axis at a distance s. Now what is this distance s? S is actually lift of follower. जब हमने previous lecture में discuss किया था that this cam is rotating and this follower is actually following the profile of the cam. So follower will move by some distance in upward direction. Okay. So total distance moved by the follower in up direction or down direction is called lift of the follower. So if you recall the angle of ascent means When the cam is at certain angle, let me redraw it. In angle of ascent, we saw that at the starting of the lift stroke or at the beginning of the lift, our cam is at this angle and follower is over here. And at the end of this stroke, cam is like this and follower is in this position. So you can see follower is lifted by some distance. Okay. So this distance by which the follower is lifted is called displacement or S. Okay, we are denoting this lift with S or you can say stroke. Okay, so draw a line at a distance. This distance is S. Okay, it may be given to you in problem statement. So on x-axis there will be cam rotation angle that we will mark according to scale. Okay, and on y-axis there will be displacement. So we are designing the cam for one revolution. Okay, so we will mark a line at the angle 360 degree or you can say 18 centimeter according to our scale. You can assume your scale also. Okay, there is not it is not necessary that every time you have to assume the scale that I have given to you. Okay. आप अपनी तरह से भी स्केल जो है वो अज्यूम कर सकते हो ओके सो यू अकॉर्डिंग टू योर अज्यूम स्केल यू हैव टू मार्क a point at the angle of 360 degree okay or at the distance according to angle of 360 degree. So this is one complete revolution of cam 360 degree. Now in one complete revolution of cam जब कैम एक पूरा रिवॉल्यूशन कंप्लीट करता है तब उसके अंदर बहुत सारी चीज़ें होती है कई बार हमारा जो फॉलोअर है वो अपवर्ड मोशन करता है कई बार हमारा फॉलोअर है वो डाउनवर्ड मोशन करता है और कई बार हमारा फॉलोअर है वो एज इट इज अपनी पोजीशन पे मेंटेन रहता है कहीं पे मूव नहीं होता है so the angle during which our follower is doing upward motion is called angle of ascent. Suppose for 60-degree rotation of my cam is rotating by 60 degree and during this rotation my follower is going up. So this angle 60-degree angle is called angle of ascent. And the angle during which the cam is rotating but the follower is maintaining its position is called angle of dwell and the angle during which my follower is going down is called angle of descent. Okay. So in one complete revolution of cam, these many things are happening. So accordingly we have to mark the dwell, rise, return, these angles we have to mark accordingly. So if you are given in problem statement that for 30-degree rotation of cam, my follower is not moving at all. So that is dwell period. Then for next 20-degree, my follower is moving up. So that is rise. So according to my scale, I have to draw this line at this much distance. So I have assumed the scale that 1 mm is equal to 2 degree. And I am saying that for 20-degree of rotation of cam, my follower is rising. So according to my scale, I have to draw this line at 10 mm. So from this line, I have to draw a line at 10 mm. So this thing over here represents 20-degree of angle. So like that, you have to mark all these other things for dwell, next dwell, return, and dwell. Okay. So angle of rise is denoted by theta O. Dwell angle is denoted by theta D and return angle is denoted by theta R. Dwell angle is present over here also and here also in this particular case. Okay. So this will also be theta D 1 that is theta d2 and that is theta d3. Okay, this angle of dual may be different in one cycle. कई बार ऐसा भी हो सकता है कि ये ड्वेल और ये ड्वेल प्रेजेंट नहीं होंगे हमारी साइकिल में, कई बार ऐसा भी हो सकता है, बट हियर आई हैव टेकन अ जनरल पर्पस, ओके, अ जनरल सॉल्यूशन. And this is our follower, that is on the beginning of the cycle, means at 0 degree. In our case, our follower is at this position. So first stroke is dual. Okay, so during dual, my follower is not moving. Okay, so means during this 30-degree angle, this is 30-degree angle, I am not experiencing any displacement. My follower is not moving at all. It is present at this level only. So at this point, my follower is on this level, and at this point also means after the end of this duel, my follower is on this level only. So my follower is not moved. So displacement is zero. You can say during dual period. Now next, after reaching at this point, there is rise. So my follower will move up by the distance s. So in rise or is in rise portion of the cycle, my follower will move by distance s, or you can say it is lifted by distance s, or you can say it is displaced by distance s. So during this much angle, my follower is rising. Then after the rise period is over, means after 30 and 20 degree. Okay, for example, I have taken it as 20 degree and 30 degree. So my cam is rotated by 30 degree, okay, and nothing happened. My follower maintained its position. Then after 30 degree, for next 20 degree, my follower rised. And as it is stated that this motion is with uniform velocity. Okay, whatever motion this follower will make, it will be according to uniform velocity for this case. Okay. So for uniform velocity is represented by this line, this displacement, linear displacement and angle. Okay, so the uniform velocity will be represented by a inclined straight line. Okay, this is straight line, not curve. Mind well. Okay. In uniform velocity of in motion of follow with uniform velocity, all the lines will be straight line. No curved line will be present. Then after the completion of rise, there is dwell period. Okay, for example, I have taken this dwell. Okay. So during the motion or rotation of cam during dwell period, my follower has maintained its previous level. हमारा फॉलोअर जो था वो बिगिनिंग में यहाँ पे था, ओके, ड्यूरिंग दिस पोर्शन. देन ड्यूरिंग दिस सेकंड पोर्शन my follower moved by distance s in upward direction, that is the second portion. Now during third portion, that is 12, my follower has maintained this position. Okay, my follower is not moving. Keep this thing in mind. During 12 period, my follower will maintain its level. Okay, अगर वो नीचे होगा तो नीचे रहेगा, अगर वो ऊपर होगा तो ऊपर रहेगा. Then next period is return period, means during this much angle, my follower is returning back to its initial position. Okay, so during this motion, the follower will descend by distance s, or it will come down by the distance s. It is coming down during this return stroke. It will be also straight line, and next period is dwell. So during dwell period, as I said, my follower will not move at all. So this will complete my one revolution of cam, means 0 to 360 degree. And this is the displacement diagram for one revolution of cam when the follower is moving with uniform velocity. So this diagram is helpful in developing the cam profile. So this is the displacement diagram for uh, motion of follower with uniform velocity. Okay, so if you are asked in exam that the follower is moving with uniform velocity, then at that time you have to follow the procedure mentioned over here to construct the displacement diagram, and this displacement diagram will use in constructing cam profile. एग्जाम में आपको 7 मार्क्स का क्वेश्चन आता है कि ड्रॉ द कैम प्रोफाइल when the follower is having uniform velocity motion. Required data will be given to you, but this is the procedure, general procedure. This will be followed every time when you are given the follower motion is with uniform velocity. Okay, so let's move to next motion. It is motion of follower with simple harmonic motion. Means my follower is now moving with simple harmonic motion. It is very common motion. You can observe in many things. Okay, one example is given here, spring mass system. So when my follower, okay, forget about this spring, only concentrate on this green color ball. Okay. Whatever motion followed by this ball is called simple harmonic motion. You can see it is oscillating about some mean position. So this kind of motion is called simple harmonic motion. And this, you can trace this point also. This green color line is actually displacement of this green color ball that is moving with simple harmonic motion. Okay, so you can use this concept in generating displacement diagram for simple harmonic motion of follower. So in this left hand side figure, this red color ball is actually tip of follower. You assume it as a tip of follower. So you can see this ball is moving up and down only, same as our follower. And this on horizontal axis, you can see this one moving in horizontal direction is actually projection of this red ball. ये जो यहाँ पे रेड बॉल है उसका प्रोजेक्शन है जो हम एक्स डायरेक्शन में मूव कर रहे हैं. So you can see this projection is actually covering this or having this sinusoidal form. So this is the simple harmonic motion, and we will use this concept in developing displacement diagram. So clearly observe this thing. What is right now? Just concentrate on this figure, left hand side figure only, and observe what is happening. This solid red ball moving up and down only, and we are moving its projection on x direction. So this motion is simple harmonic motion. So now let's have a look at how to draw the displacement diagram of follower with simple harmonic motion. So first beginning is same. Draw the x and y axis according to scale. Draw a line at a distance s, that is displacement or movement of follower, and on x axis assume a proper suitable scale and mark a point at an angle of 360 degree. Means the distance corresponding to 360 degree according to your scale. जो भी स्केल आपने एज्यूम किया है उसके अकॉर्डिंगली कुछ डिस्टेंस आएगा, वो डिस्टेंस यहाँ पे मार्क किया है एक्स एक्सिस पे, दैट इज रिप्रेजेंटिंग 360 डिग्री. This is the 360 degree distance, and in this simple harmonic motion I have taken only three parts: rise, dwell and return. Generally these three are important. Dwell, you know that during dwell period my follower is not moving at all. So wherever there is dwell mentioned that for this much angle there is a dwell period, then your follower will maintain its position. It is not going to move anywhere. So no matter whether your additional value is provided or not, or on that side, you know that during dwell period it will maintain constant line. Okay. So I have shown here only three portions: rise, dwell and return. Now the procedure for drawing displacement diagram with simple harmonic motion is theta 0. Theta O is the angle of ascent or angle of rise, you can say. Theta D is the angle of dwell and theta R is the angle of return. Means during this angle my follower will return from this position to this position. That is the angle of return. And angle of rise is my follower will move from this position to this position. That is angle of rise. And this is my follower initial position. So for drawing the simple harmonic motion, I am here drawing a half circle. Okay, you have to draw a half circle because observe in previous slide. Let me show you. As I said, I am going to follow this concept. So I am just showing the half circle, this much portion. So draw the half circle. Now divide this circle into 6 equal number of parts. 1, 2, 3, 4, 5, 6. Okay. So this half circle is actually making 180 degree. So divide this 180 degree into 6 equal parts, means mark the points at 30 degree. Okay, so that will divide the whole circle into 6 equal parts. Then connect these points with center. So now mark the numbering like this, starting from 0 over here bottom, then 1, 2, 3, 4, 5, 6 in clockwise direction, and 7, 8, 9, 10, 11, 12 in opposite direction, counter direction. Now divide this rise portion, it means this angle theta 0, into 6 equal number of parts, because here we have divided this circle into 6 equal number of parts. So we will divide this rise angle into 6 equal number of parts. So suppose if my angle of rise is 60 degree, okay, then this one portion is actually representing 10 degree. So you get it? You have to divide this rise portion into equal 6 number of parts. Also divide this return portion into 6 number of parts. So it may happen that angle of rise and angle of return may be different. For example, in some example, the angle of rise is 60 degree and angle of return may be 120 degree. It may happen because this complete angle is 360 degrees. Out of them, 60 degree angle is for rise and 120 degree angle is for return. So at that time, this one portion will represent 20 degrees. So in many examples it may be different, or in some examples these angles, angle of return and angle of rise may be same. I have taken here general condition. So steps are: first, draw a semicircle over here, divide it into six equal number of parts. Then mark the numberings 0, 1, 2, 3, 4, 5, 6 in clockwise direction and 7, 8, 9, 10 up to 12 in counterclockwise direction. Then divide this rise portion into six equal number of parts because we are dividing this circle into six number of parts. And similarly, divide this return portion into six equal number of parts. These, these parts should be equal. Now, draw the horizontal projections from these intersections. You can see we are drawing projections from these points 1, 2, 3, 4. Whatever these points are there, we are drawing horizontal projections. Now, at the intersection of this one line, vertical line, and one, that is horizontal line, will mark the point, this point. Similarly, at the intersection of these 2 and 2, we mark another point, and 3 and 3 will mark another point. So, likewise, mark the points at the intersection of these lines, like this. At the intersection of one and this horizontal one point, then at 2 and horizontal 2, another point, likewise, this much amount of points. Similarly, on this return portion, similarly mark the points, that is on this line which is also representing 7. So at the intersection of this 7 and 7, I marked a point. Then at 8 and this 8, mark another point, likewise up to 12. And give the names small a, b, c, d up to f during rise period and g, h, i, j, k, l, m during return stroke. Okay. तो हमने जो यहाँ पे पॉइंट मार्क किए थे उन पॉइंट्स को हमने नाम दे दिया है ए बी सी डी ई एफ लाइकवाइज. Now join these points with a smooth curve. आपको ये points जो है उनको smooth curve से join करना है. So now you can observe when my cam is rotating by the angle of 0 to theta O, my follower is moving up. Observe over here. My follower is moving up. So that is the rise period of follower. And next portion is dwell. For this much amount of angle, my follower is not moving at all. You can see my follower did not move. And during return stroke, join these points with smooth curve. Okay, that will complete our return stroke. So now you can see my follower came back to its initial position. So this curvature is actually representing simple harmonic motion. So this is how you are required to construct a simple harmonic motion or displacement diagram for follower that is moving with simple harmonic motion. We will use this displacement diagram in constructing the cam profile. Okay. How we will use, I am giving you the hint now. Okay. Suppose for example, my angle of rise is 60 degree. Means for 60-degree rotation of cam, my follower is moving by the distance s. So how we will construct that? We will measure this distances and mark the points on the follower. You will get a better idea when we will draw it actually. Okay, now I am giving you just a hint. As I have divided this angle of rise in six equal number of parts, so this one portion is actually representing 10 degree. This is another 10 degree. Likewise, so on. So you can say for 10-degree revolution of cam from here, if I revolve the cam by 10 degree, my follower will rise by this much amount. ये जो 1 to small a जितना डिस्टेंस है मेरा फॉलोवर उतना ऊपर मूव होगा. Then if I move further 10 degree, my follower will rise by the distance 2 to b up to b. Okay. मेरा वो जो फॉलोवर होगा उसका पोजीशन यहाँ पे होगा, इतनी हाइट पे आएगा. Then after another 10-degree rotation, my follower will rise up to point C. यहाँ तक आएगा. So we will measure this distance and mark the arcs on drawing the cam profile diagram. So this is the displacement diagram that we will use in developing the cam profile. So that is the concept of motion with simple harmonic motion. One more time, observe the motion of the follower. Okay. Now the motion is smooth. You can observe this. And you have to connect these points with a smooth curve, not straight line. Because ये यूनिफॉर्म वेलोसिटी नहीं है, ये सिंपल हार्मोनिक मोशन है. So you have to join it with smooth curve. अगर आपको दिया गया हो कि यूनिफॉर्म वेलोसिटी है then you have to use straight line. Otherwise every time you have to use curve. So this is the curvature, not straight line. So अगर आप कंस्ट्रक्ट भी करते हो ये, तो एक बात आपको ध्यान में रखनी है कि आपको सिंपल स्केल से ये पॉइंट्स जो है वो ज्वाइन नहीं कर देने हैं. आपको स्मूथ कर्व ड्रॉ करना है जो इन सब पॉइंट्स में से पास होता है. एंड फॉर ड्राइंग स्मूथ कर्व, if you are good in drawing, you can do it with free hand. If you are not good in drawing, then you can use the French curve that you have borrowed in EG. Okay, that you can use here also. You can use this curve with French curve. So this is the motion of follower with simple harmonic motion. Okay, and one more thing. Here I have taken 6 divisions. You can take 12 also. If you take 12 divisions, then you will get more number of points over here. अगर आप यहाँ पे इस सेमी सर्कल का 12 डिवीजन लेते हैं, 12 डिवीजन, तो यहाँ पे आपको ज़्यादा नंबर ऑफ पॉइंट्स अवेलेबल होंगे. तो आपका जो कर्व होगा, योर कर्व विल बी more smooth as compared to this one. But generally 6 divisions are optimum. They are not bad at all. Okay. So in example, you can also take 6 divisions. Okay, I'm just telling you that if you take more number of division, then you will get more number of points over here that will make your curve smoother, or you can say accurate. जितना ज़्यादा नंबर ऑफ पॉइंट्स आप यहाँ पे लेंगे उतना ही ज़्यादा एक्यूरेट आपका मोशन आएगा. But if you take more number of points, it will consume more time in solving the example. So we will limit it to 6 divisions only. So that is how you are required to draw the displacement diagram when the motion is simple harmonic. We find then next 2 types of motion we will discuss in next lecture because we are in limit of time.